Hello and welcome. I'm Bill Wake. We're here working on an Elm interpreter. We've been working on infix expressions for a while, and now we're ready to work on the operators. We've got some of them working plus, minus, and times, and we got some that we just don't have the right operator for in our Swift interpreter, so we're going to add that today. All right. I'm a little off kilter for some reason. Let's see. I think well, I was planning to be running tests by this moment. Okay, let me get a little set here. Get the chat on. All right. Let's try again on those tests. All right, so what do you have to do? Here's plus minus times. Exponent did not work. And we got to do float divide and int divide and turn that into an error. So I think at some point they had a modulo operator, but because JavaScript maybe defaults to remainder by instead of modulo by or something, they thought it was confusing, I believe. Let's see. Okay, it is starting slowly. All right, let's just find where we are in the code. Okay, things are going to be slow, I guess. Okay, I don't think it's frozen. But it's not very responsive either. Well, I think I can talk about what we have in place so far. We have you can have an operator or a function that takes two integers or floating point numbers and returns another one. And plus, minus, and start are kind of like that. They have an integer version and a float version. We have a function that takes two arguments. It takes two functions as arguments, an integer version of a function and a float version of a function, and it helps link that two argument function can be linked into our interpreter. And we have another notion called currying that takes a two argument function and turns it into a one argument function. So between those two things of accessing the actual function and treating it as a curried function, it's compatible with Elm the way we're going now. Okay, and I'm getting a network error too. Okay, let's see. Hold my hand up. Eventually I'll see that on the screen, I hope. All right. It seems to be back. This is still taking its time. Wow, it's got the iPad open, but it hasn't launched it yet. All right. It seems like what's going on is I've got a Windows environment running on the side, and it's in the middle of updates. So I don't know if that's what's slowing things down so much. This is pretty ridiculous. All right, we are at least opening our application prior to testing it. And it looked like it might let us navigate now. Okay, so primitive functions test, we left off. Okay. Yeah, we'd like to make it, we'd like to know that there's some integer power that works. Let's see what we have here. Okay, so yeah, this primitive functions is sort of our link between low-level arithmetic functions and our expression environment. So getting it up in here, we're symbol table enclosure. That's all the expression level. We got the sums. So the plus, minus, and times work a particular way with int versus float. There we go. Okay. And this we've got done. That's a good thing. All right, let's go in there. Okay. So we have the int power a to the b. All right, we don't have a float power. Let's find our example. Yeah, there we go. We got pow by itself is a float. Okay, so I think what that says is we certainly can do a prefix operator like this. Let's find my environment. Elm-REPL. Okay, so if you say 2 to the 3, you should get 8.0, a float. Oh dear. Okay, well, it's a number. And it's 2 integers to their powers. I don't know if we can try that. Okay, float. Still an 8. And we can do this 2 to the 3. So we treat it as a prefix. Treat the operator as a prefix function. All right, so the type becomes float. Now let's. I think we can just run this, and we should be able to evaluate. The prefix form should work now. It may have worked on the other day. Arrow. Wow. Okay. Oh, there, it lost it. All right. Prefix arrow 2, 3. We hope this works. Yes. Okay. And similarly, prefix arrow 2.0, 3.0. Float. Okay. That spacing. We had a little better padding at one point. That seems worse. Okay, let me add that to the to-do. REPL, check padding in upper box. Okay, so we have this operator in prefix form, but not infix form. So 2 to the 3, we would like it to work, but it doesn't. Okay. It's got the wrong number. That's even more disconcerting, isn't it? All right. Let's see. How can we track this down? All right. Well, we're at a green bar. Let's commit this. Target integer prefix power operator. Okay, now we have, here's operator tests. Let's get to operator. Yeah, operator's the real argument. Yeah, okay. We have our functions plus, minus, star, but we don't have power on that list. All right, so let's find the operator tests, and we got to evaluate that. Let's evaluate power expression. Okay, so if we have token dot up arrow, I guess I can remember 3 to the 4 is 81. That's actually okay. Okay, up arrow 3481. All right, let's... Do I dare run all the tests? 0.647 seconds. It actually took about 5 minutes. Yeah. And I'm just going to bounce over and see if I can shut down Windows yet. Installing. Okay. We're still building here. Okay. And we expect this to fail. We don't have that operator in there. But from primitive functions, we pretty much know we want this. Not yet implemented. Okay, that's actually a good thing. And we'll just add up arrow. Well, I guess we don't need to do the curry here. Primitive functions dot. And this should pass now. Zero failures. All right. Okay. And let's run the REPL. Okay, so 2 to the 3 should be 8. Oh, and it's still not. Well, maybe it would be interesting to know why it's doing anything. Oh, if op functions equals nil, returns super evaluate context. That's probably, well, that's hurting us. Super evaluate probably just returns its left argument or something like that. Super is just expression, which is our parent class for all these. And it gets error expression not implemented. Oh, so this is not working the way I expect. Operator. Excuse me. I'm just going to take a look in here as we're going. That seems really odd. Well, there's two oddities, aren't there? I guess it's reasonable. I mean, we seem to be evaluating it properly here, because when we did this, it passed its test. So it's an up arrow 3, 4 is 3 to the 4th, which is 81. Op is up arrow. We have a function of some sort. It's not nil, so we're going to return op function sub op on left side, right side. Let's step over that and into that. We came out. Well, let's just continue at this point. Okay, executed one test with 0 failures, so it did get the right result. I don't know why it didn't stop at int power with us, but okay. Now, what confuses me is, well, our run 2 to the 3rd returned 2, so it's just returning the left-hand side. It's like we're not doing something. Super value, it gives us an error expression, so you think that would just complain and be done. We've seen errors before. Okay, if op is nil, meaning there's no operator found. Okay, let's look for this. Well, here's our parser. Let's make, okay, up arrow is there, right? Precedence. So we put in all the operators, which that's something. We think it works on the table side. Let's keep our same breakpoint and see what happens. We're still breaking there. Let's do a run. And we'll just do 2 to the 3 again. 2 to the 3. Evaluate should take us to that breakpoint, and does not. All right, so that makes me suspect our parsing is not picking up arrow 3. Why that one would not be doing it, I don't know. Okay. Let's see. Precedence Parser tests. We have this test with an up arrow. Operator token up arrow. All right, so given this test, a times b plus c to the d to the e times f. Okay, we expect c to the d to the e to be right precedence and done before the times f. All right, so we feed in a times b plus c up arrow d up arrow e times f. We get back the this is the postfix order, so left, right, root. Left of the tree is A, then B, then a star. C to E has to go up 2 levels to get the up arrow because it's right precedence, and then star, and then plus for the overall expression. Okay, so in that sense, I feel like it's well, this is the precedent, the normal parser. Let's see, parser is a precedence parser. So if you feed this into our precedence parser, you get back this, and then we have another. Let's see, where's our other parser? Well, we have this postfix thing. Let's find that. Post order. So if you feed in the post order, it produces an expression. All right, so let's break here. Yeah. And we're still there. Okay, 2 to the 4 is 16. We did not break. Oh, I busted something. How do we not go here? All right, I guess we're back to our main parser. Oh, golly. So our main parser, we have the precedence table, all the operators. We have the precedence parser. We have to make sure it's being called at the right time. Operator expression, that's one we care about. Token is operator. Let's see how that's defined. Is up arrow on this list? No, it is not. Okay, so we missed an operator. Actually, we missed float divide, int divide, percent. Percent is probably not really legit. Double equals. Well, we don't have up arrow, so that's a problem. All right, who calls this? Caller. Operator expression. Annoyed with this. So post order, we don't think there's a problem. Don't even think there's a problem here. I think we're done with this one for now. It's a parser. Well, I never know whether to explicitly test these. You know, it's just like, it's checking this list against itself. I don't know. But we do know up arrow should be on this list because it is an operator. So let's run this. And make sure it works, and then we'll figure out what to do. 2 to the 3. Okay, so that works now. So I think that explains the issue. So our operator parser is supposed to pick up numbers or in values, names, followed by operator, and then more expression. But we said arrow is not an operator, so it just skipped forward. And apparently ignored the operator and the rest of it. It seems a little weird, but like, how do we want to test this? I don't know. maybe a high level test of the whole thing. Can we do that? Well, maybe the parser tests. I don't know. All right, let's check. Tuples with power infix expressions. Okay, it's not a tuple, it's just a power infix expression. 2 to the 3. And we don't expect a tuple, we expect an operator, up arrow, 2 and 3. Check successful parse. Oh, Elm type. I don't think we have that on there. It's the parse. And there's an extra. That. Okay. Let's see if that works. At this point, it should work. I think I put that back in, right? Or took it back out. Where is it? Well, it should work if and only if, yeah, it should fail at this point. One failure. Okay, now this, it should pass. Okay. And let's see. My speaker, oh, there it goes. Speaker seemed to be off. All right. That's good. Let's run it one more time. One more check. Well, 2 more checks. So 2 to the 3 is 8. 3 to the 8th is probably still expressible, right? So let's do 3 to the 2 to the 4. That should be 3 to the 16th, which is 81 times 81, I think. Let's 3 to the 16th. Can I do that here? Yeah. Okay. So that tells me we did do right precedence, because if you did 3 squared to the 4th, 9 to the 4th, do you get a different number? Yes. Okay. So it does support the right precedence as it's supposed to, and it handles multiple ones. Let's do it a floating point one. 3.0 squared should be 9 float. Okay. Yeah. All right. I feel like I'm waking up Monday here. Let's see. We're going to say we're supporting for int and float. Okay, my neighbor's cutting the grass. I hope it's not coming through the mic too badly. All right. So that means we've accomplished something. We've done part of our infix operators, 21-043. Typed it on the first try. And we handle power. Okay. Now we'd like to do integer divide, float divide. And we want percent to be an error. All right, so this one's a little funny, and I'm not quite sure what to do about it, but up till now we've had these functions that support both integer and float. Now we want an operator that only supports float, but I think we should be, I don't know, let's see what happens. If I say 3.0/2.0, it should fail because we don't support divide yet. Okay, not implemented syntax. I can live with that for a message. If we do 3/2, well, we're going to get the same error, but the error is, well, let's see what happens over here. 3/2 converts it to float. Okay, so if you do addition, let's actually do it, I guess. Better than talking. 3 plus 1 is two integers. It says they're numbers and computes the sum as a number. 3.0 plus 1 should convert it to float. Okay, that's fine. If you 3.0 plus 1.0, if float plus float, yeah, it's a float. So with the plus operator, it accepts number to number plus number goes to number, like this. Or if there's a float involved, it says convert it all to float. Number plus, float plus float goes to float. The slash operator is different. It says I just deal with float. You want to divide? You got to convert me to a float and divide. So number can get a free conversion to float. I find this like the ugliest part of Elm. I don't know. There's weird stuff. Yeah, it's unfamiliar, I guess, right? That's half of it. But I think the semantics of how you mix float and int, it just seems very special casey. All right, so plus, minus, and star, convert any float, convert the whole thing to float. Divide, oh no, convert it to float and then divide. You can't get an int out of this operator. And then the / is the opposite. 3/2, it knows I want ints goes to int. If you do this, I don't know what happens. All right, yeah, it complains. So converting int to float is free, or number to float. Converting float to int on this via this operator is not even supported. It doesn't know what to do about it. It leaves me not quite so sure what to do in our code. I have the notion of an error expression, and maybe that's the result, just like this thing appears to be. But yeah, so the operators, there's different conversion categories. So let's see. So I think what this means, we have to deal with operator. Okay, so we can't do / by analogy to this one. We have to have a new function that converts ints to floats and then divides. We can use divide for the right-hand operator because it's just a floating point divide. But let's go in primitive functions. If I have it up, no. Parser. Okay. Well, let's do the thing we know how to do. All right. So I would like to test float divide of integers. Converts int to float, then divides. Okay. Now, I thought there was, somebody did something that made it look like this might actually be a thing. Is that really a thing? No. Okay, let me undo. Okay, test float divided integers, converts int to float, then divides. Okay, so I want to say, well, maybe there's just a float divide of integers. 3, 2 goes to 1.5. Okay, and we don't have this method. Primitive functions. And we're going to make something by analogy to this. Okay, into float divide of integers. Okay, you got A and B, and it returns a double. Okay, and let's just return minus 1.0 for now. Okay, and our test should fail. Okay, one failure. We saw it go by. Well, we know what we're looking for. Let's just look right here. Minus 1 is not equal to 1.5. Cool. All right. So now this function is really just convert to double. So return double of A divided by double of B. Okay. So we added a function to do double division of two integers by converting to double first. All right. I see by the clock it's just about time for a break, so let's take a break. What we're going to do when we get back, we're going to plug in float divide of integers with the normal divide. Well, that affects the other place more than here, but in the operators, we want float divide of integers. Okay, so we will come back and take care of that. All right, 2 minutes or so. Thank you. Hey, welcome back. Well, I don't want to be a spoiled sport, but I'm expecting some trouble here. Everything else is trouble, right? Why should this be different? Okay, so the challenge I see is that right now we say slash gets you slash or slash. Well, integer divided by integer slash is not the same as what we just wrote. So I honestly think that code up there should be using this. Now, I got a feeling it's not going to like that. Right, because it wants an int function or a double function. And so we have a situation. I mean, this convert to thing, the rules are different, I guess. That's really what it comes down to. Because this is the one that convert to says if they're both ints, we'll return an int. If either one's a float or both, we'll return a float. Otherwise, we'll return an error message. Well, otherwise it can't really be a problem, but just in case, I guess. But we have a function that is int goes to double. Okay. So what that tells me is if we run it and use the prefix divide operator on 3, 2, we will not get 1.5, I don't think. I'd be very shocked and more confused than I already appear to be. All right, so divide 3, 2 should give us 1.5 float. It gives us one number, so it's doing an integer divide. All right, that's the problem I thought I had. Well, what it may mean is I mean, this is really a different rule, right? The rule here, I mean, I could have an int. Well, no, I could have a double double. Yeah, I guess what I want. Um, Maybe isn't this at all? Well, there's no harm in that. Okay, convert's got to be different though. That's for sure because he doesn't like that. So we want to say, what happens if you call convert? Well, let's find some tests for convert too. Great. All right. We're testing a level up, perhaps. Oh, okay. There's that security reboot. Let's see. Convert. Well, how are we testing curry? Okay, that does not seem like. That's not how I remember it. I remember doing something. Yeah, we're calling convert too. Okay. I guess we need. Oh, I guess we need combinations. Like, okay, what's another case? 1.0, well, 5.0 divided by 3 converts everything to float. So any argument, basically this thing is convert everything to doubles and then evaluate. Okay, so I think let's do test divide integers turns to double first. And we'll just get it into float. Well, this is probably closer. All right, so convert primitive functions. We got x and y integers. Let's make this 5, 2, 7, 2. I don't want to get a 2 as my answer when a 2 was my input. So this answer should be 3.5. Okay, so this is a double value, 3.5. And we're going to call this convert to double and apply the operator. Takes 2 arguments. Yeah. Okay. And double value, that seems legit. Oh, float value. Okay, float value. This does not exist. And it's only going to take one function. Okay, so, well, we'll just steal it for the moment. It's subtle little rules. I mean, the differences between them. No, we don't need an int function. We just need a double function. Double goes to double. You give us a function that takes doubles, we will do the work. Okay, so if, yeah. Basically, we don't care if x and y are both integer values. That's not really something we care about. Okay, but let's just return integer value 3. All right, just to get, we're trying to see our test fail. Divide integers, convert to double first. All right, let's see what that does. Doesn't build. Has no function convert. Oh. Yes, code after return will never be executed. That's fine. All right. Fails. Oh no, it didn't fail. Oh, what a great, no, wait, 7-2. Yeah, let's return -1. Thank you. So the one value I pick is the one that if I truncated, I would get, you know. Oh, goodness. Okay, so now if that failed, we can do the real thing. All right, LHS float value as float value. If it's an integer value, convert it into a float. Yeah. If it's the right-hand side is an integer value, convert it to a float. If they're both not nil, meaning they converted properly, then return float value of double value of their values. Okay, I think that looks correct. Okay. What did we get? 9.0. Oh. Let's test divide, shall we? Okay. So we've got a add a convert method that takes a double to double. I guess we'll say it takes a pair. Double returns double. Maybe take a function that converts arguments to double and applies it. All right. So this is really the conversion rules. And hopefully, well, let's go back up here. What I definitely see is duplication. This is very, very, very similar to that. And either of them is identical to the one beneath. All right, because we copied it. This conversion, then we can make something that does that. We're going to convert. Well, what are we doing? We're converting int. Well, let's see what this thing is. LHS is float value equals x as float value. So convert it to float if you can. If you can convert it to an integer, so it might be nil. If you can convert it to an integer, then we assign the float value of the conversion. Otherwise, the float value has its thing. Okay, so the bottom line is we get LHS out. I don't know if we can. Whoops, sorry. I was trying to. That's not the right one. I was trying to extract a method and okay, it does not. All right, well, let's manipulate it until it is. So the input is x in this case. We don't reference x beneath, so I think I'm okay. Let me do it the manual way. Okay, and this is a static function, convert int to double. It takes an expression and returns an expression. Okay, it takes, well, we'll call it x is an expression. If x is floating point, okay. I guess I can live with that. Is it even float value? I guess that's probably the real thing. Okay, x could be an integer value or a float value or some sort of error situation, I guess. If x is a float value, assign it if possible. So it assigns nil or float value to LHS. If it turns out x is an integer value, then change that thing. Okay, so I should be able to call this on my x up here and say var LHS equals this of x, and these three things should be okay. So convert int to double. I guess let is fine. The method's going to do all the work. And let's see if this works. And I guess I should use float value. Let's do double. Double's Swift. Float is Elm. Well, Swift has floats too, but all right. Let's rename this. Rename field. Okay. Let's try it down here. Rename. I'll say integer to float. Okay, good. Now let's do the same thing here. RHS equals convert integer to float of y. That's these three lines. And I think that's reasonable. I mean, this has got some similarity, but it really is a different kind of way of doing it. So if it's integer, if everything's integers, do the integer function. If not, then try and convert things to floats and do the float function. Otherwise, you must have some sort of error situation. Okay, so let's, I think we can even just take these two lines, being as we more or less copied. Okay, so that takes care of these lines. This one we convert to double. Okay. And everything should still pass. Okay, and now I want to look at this method. I'm going to move it down. Okay, I don't like doing that with blocks like that, but I think I did it correctly. Okay. Now I'm not happy with these names, so let's rename this to result. And I just use that as a consistent name for a return value I'm accumulating. And this, I think, can just be input. Okay. So convert it to float if you can. Otherwise, try and convert it to int. And yeah, then return whatever you get. Okay. I think that's good. Let's take this breakpoint off. Okay, so our bottom line of this is we refactored convert functions. I guess I can say it that way. All right, now the function here, we got to find somebody who's doing an evaluate of these prefix operators, I guess. We did that before, back at the high level. Was it interpreter test? No. Oh, operator test maybe? No, that wouldn't apply to those. Where did we do that? Interpreter tests. No, that's just simple. Expression, no. Can I tell from what I checked in? I don't know. We didn't tag anything, so that's not going to help anything. I don't know if I can. Yeah, I should be able to see this. No, I thought I could select on this. Maybe it's up here? Yeah. Okay. Function of double division of integers. Okay, well that verified that our float divide worked, but we don't even need that now. Okay, so that's, let's see. We need a test of we had it. Sorry, I can't remember which file. Operator, primitive functions. Primitive function tests. Okay, yeah, it was primitive function tests. Okay. Our last one, yeah, I think this is actually not needed now. At least for this one. But what we need to do, we need a... I'm surprised we don't have an example of a prefix operator, I guess. That's kind of what's getting me. All right, but I think this was wasted work. Convert to double. Let's go back there. Oh no, convert to double is okay. Float to divide of integers is unnecessary. I think this is what's unnecessary. His color is that. But I think that's repeating the work as why, even though it seems like the hard way. This thing does the conversions, but we just made this bigger function that did convert to double. And so I want to use this one and just pass in one slash operator and have things work. So I don't think I need this because it's doing a double slash divide operator kind of thing. So this can go. All right, now what I don't see, what was test curry? That's definitely more complicated than I want. Where can I test? Let me run. I think maybe we're missing a level of tests that we've just kind of picked up implicitly. All right, so we want to see the error that happens here. So the error is if I do this, I should get 1.5. I don't. Okay. Now that unknown syntax, that seems a little suspicious to me. What about this //2? Okay. Maybe that's reflecting the same thing. Oh, we don't support those. Yeah, we haven't implemented that, but we have implemented this. Now, right now, I think it says 1. It should say 1.5. And /3.0, 2.0 should say 1.5. Those two should have the same answer. Okay. Yeah. Now, where's that going to get picked up? Oh, typed it there, did you? Okay. So I would like something on primitive functions. The trick is, by the time I call through this, we've got a curry operator going on, and so we're converting this thing to that takes the 2-argument function here and converts it to a 1-argument function, yielding a 1-argument function. But maybe that's okay. Returns a primitive. Well, somewhere we need to evaluate a curried expression, and maybe that's all we can do. To a 1-argument function. Right, so here we've converted it to plus. Let's repeat this test. Oh, yay. And then we'll simplify it. Okay, curry with float divide. Okay, so the function is convert to double of slash. Okay. And can I go up a level? I mean, what if I just evaluate this? Prefix operator sub that. Let's Let's try just float divide. Prefix operator float divide. Okay, so I'm going to say let function equals, and then I just want to use this table. I'm a little bit snooping, but it's public for others to use, so I don't know. That. Okay. That thing should be a primitive. I'm the wrong thing. Primitive functions dot. Okay. Okay. If you ask for this function, you should get a primitive function, I think. An expression. We can live with that. Okay, because we know it's a curried expression. I guess curry is, you give it stuff, it returns you an expression, which is type expression goes to expression goes to expression. Getting buried here. All right. Now what they did with this thing is they said, okay, let me make this function 1 again. I think that's the equivalent of doing that. Then we want to take function 1, apply it to 7. We don't care about so we have to know it's a primitive. Wow. Okay, so now we have apply if it is a primitive. And this is being a little snoopy, I recognize. But we're going to apply it to 7 and then apply that to 2. And we expect a result that is a float value of 3. Okay, let's see if we can make sense of this whole thing. Okay, so we're going to look up the prefix operator /, which is float divide. We're going to apply that operator to the integer value 7, so that's the first argument. Then we're going to take the result of that and apply it to integer value 2. So we should get 7 divided by 2, and the result of that should be a float value 3.5. This should fail because it's going to come back with an int value 3. I hope. Three is not equal to 3.5, right? Good. Okay. Ugly as it is, we're failing for the right reasons, so I think that's something. All right, so now what I want to say is that's because I got the wrong function here. I have convert to with the int divide. I really want convert to double with double divide. Okay, so all the others, they use convert to, so they take an int function and a double function. This one's going to convert everything to doubles anyway, so it just needs a double function. And I hope this test passes. Yes. Okay. So what we've done is we made the prefix divide, prefix float divide work for integers. That is int cross int goes to double. Well, float, I can say. Okay. That's fine. All right. That covers that one. What we don't have is the operator divide. And how did we test this last time? Oops. Let's find references to up arrow. Operator tests, I think, yeah. Evaluates power expression. Okay, so let's do the similar test. Let's do a float. Okay, evaluates, whoops, float divide expression. The token is int divide, float divide. Let's get something that, well, 3.2 should be float value. Oops. Float value 1.5. Okay. And we don't have to worry about precision because we know we can get a half in a binary floating point. All right. This test we believe will fail. Because, well, I think it's two reasons, but we'll get one working. One failure. Okay, and we're getting a init value. Oh, not implemented. Okay, that's true. Okay, so if we had float divide, that thing should map to primitive functions dot convert to double and our slash. Okay. Now you may notice we have some duplication in some sense of between the operators and those prefix operators. I don't think that's, I don't know. It would be interesting to map these up to their prefix operators too, but where we are right now, I think we'll keep it as is. But yeah, future optimization, right? We have this operator node that operates on the two values. It's very similar to this function call node that takes the two values as a function call and passes in the operator function the prefix operator. So there's a tie-in there we probably could take advantage of and maybe get rid of the operator node. All right, this I believe should pass. But I'm still bugged by our parser. Yep. Where's that is operator token thing? Oh, token is operator, yeah. On token, I think that's good. All right, so let's try it for real now. I thought these would go faster today. Sorry. That's optimism. Every programmer seems to have. Yay. Okay. So 1.5, instead of doing an int divide, it converts them both to float and then does the float divide. And same thing for floats. Well, we can do mixed or we can do floats. Right. Nice. Okay. So we have the float divide is working. All right. Now we want int divide by the same reasoning. Okay. Int divide. Well, let's look at what's going on here. We don't even have int divide in our list, so let's do a test for that. And oh boy, this thing. I want to parameterize this. I guess that's what it comes to. Now, are we going to pass an integer value 7, integer value 2, and float value 3.5 and the operator? I don't know. By the time we do that, we maybe will. All right. So if I say let operator, we'll just say op because it's a reserved word. But if I do op, okay, and I let left-hand side equal this, and let's see if it'll extract a variable. Sometimes it likes to do things for you. This is RHS, and it's not referenced above here, so we can certainly move it up. And then this is expected. And again, I'll move it up. All right, now I've segregated the initialization from the actual work. All right, and we can extract a method. And this thing is, well, let's put it above. All right, op string, up, left, right, expected. All right, so it's check prefix operator. Okay, and I usually call them check when there's these helper functions like that. And I also usually move them below. I don't know. Sometimes it's helpful to have them up top and just, here's what's going to happen. Okay, so given that, I can inline these manually. Yes. Okay. Okay. Well, let's just say prefix operators, and we'll do it kind of, I don't know, it's not exactly parameterized, but it's our compromise. All right, if you divide integer value 7, integer value 2, you should get integer value 3. Okay, and that also tells me I probably got the wrong types here. Yes. Let's just convert them all to expression, if it'll let us. Okay. I probably should have extracted and checked in and then added my new thing, but the new one should fail. Okay, found a nil. Now let's go to prefix operators. There is no, there's that one. Okay. Now this convert to double is not the right thing. It's really like, it's only working on integers. I'm not liking my naming scheme. So it's what is this? It's convert for integers. Or convert integer function. Maybe that's integer only function. And then this can't be right. Okay. Well, we want a function that's convert integer function. And it takes, well, it takes an int function. And it returns, I think, just an expression. Oh no, it returns expression. Expression goes to expression. Okay. All right. And did I call it integer only function? Okay. So an integer only function. Now, can I use convert only function with property? Oh, I gotta make it static, don't I? Okay. Oh, I'm stacking things up too much. All right. So what we're saying is if you get the integer divide operator, we're going to have something that only takes integers or only returns values for integers and applies divide, which is an integer function. That's okay. All right. But the real thing is we got to do this kind of conversion. And I think the double one is actually kind of closer in spirit to what we want. Well, actually, this may be better. Okay. So we get xy. That's the two arguments coming in. If x is an integer value and y is an integer value, then they're both integers. Everything is good. Call the integer function. If not, this is no longer cannot happen. Well, let's leave it there for now. This should pass our test, I think. Okay. And it implies to me there's another test. Okay. Let's make this test. If you apply operator this to one of the values being a float value, then you should get back an error expression with error messages dot int divide doesn't handle float. Okay, and let's go to error messages. Okay. All right. Now this test should fail because we got the wrong error return. I think we'll get cannot happen. Do I have to pass the location? We'll see. Internal error should not happen, does not equal integer divide. Okay, so let's use this under the circumstances in here instead. So we're being more specific. This is error messages dot. Should be green. Should beep at me, and I don't know why it's not doing that. Whoops. Let's run it now. Okay, so if we see int divide of 3, 2, that should be completely fine. If we do int divide of 3, 2.0, that should be a problem. Yeah. And if we do it directly, should get a 1, but it doesn't. All right. So we got the prefix operator. Okay. All right, now the operator tests. We've done float divide. I guess we should do an int divide. So if we do int divide, which is / excuse me, this should get an integer value of 1. 3 divided by 2 is 1. And we expect the test to fail. Oh, okay. We failed. It probably gets 1. Okay, not implemented. That's fine. All right, let's take a 2-minute break. I'll get a drink, and we'll be back. Hi, welcome back. All right, so we left off. We don't handle this int divide expression yet. And I think we find here, yeah, we just don't handle it. All right, but we know what to do. So int divide. Int divide should get a primitive functions dot convert int only function with slash. Okay, and this is the integer slash. And I think that's it. They don't have to all be totally painful, right? No failures. Okay. I don't know what's up with my mic today, or my speakers. All right. Those work. Let's run it just to see it. There's some sound. // 2 evaluate. Nice. 3 / 2.0. Integer divide can only take integer values. All right. Good. So we did both these. It gets to be a bit much with the plus signs or bullet points, but all right. What else then? semantics of underlying other operators. Well, that's kind of what we just did, except for percent. And basically, percent should get an error every time. Let's go to the real REPL. 3% 2, well, 21, whatever. If you want behavior of percent like JavaScript, switch to something else, to remainder by. If you want regular old, good old American modular arithmetic, then you want mod by. And they work differently with negative numbers, where I think mod by just slides it forward by its number until it's in range, and remainder by maybe sort of moves them all towards 0 instead of that. Modular arithmetic, you get 0 to n minus 1 for a modulo n. And remainder arithmetic, I think you can get a negative number. Okay, but anyway, let's make that get a message. And so this is a function, interestingly. It's sort of a fail function, or an unsupported function, maybe that's the better way to say it. Yeah, it should just get a message. And I don't think we handle prefix either in non-function. Okay, so let's do it on the, oh no, we need support from this thing. All right, so this case we want to convert to a failure function, basically. And maybe it doesn't need anything. Maybe it just needs an error message. Yeah, that's probably what it is. It's an argument. I mean, it's a function of all these arguments. No, it doesn't need that. It's just a failure function. All right, let's try it. Well, let's do it at this level. All right, so if you do percent integer float, doesn't matter, you should get an error message that says, how about percent operator not supported? Okay. And add it here, static let operator is not supported. I'll just say use remainder by or mod by instead. They got a better message than me, there's no doubt, but that's what I'm asking for. Okay, this should fail. Okay, yeah, that's a failure. It's a little awkward. All right, but here, the function percent okay. Cannot find convert to failure. That's fine. Okay, so we have that. And I think it's going to complain, so I'm just going to make those ignored. Expression. You give me a 2-argument thing, I give you back an expression, which is the message you gave me. And nil. Did I name that differently up here? Accidentally. Okay. Now, this... string. Okay. I don't know what's up with that. I was able to shut down that Windows environment. I'm hoping that helps a little bit the rest of the session. Okay, so at any rate, we have we're handling this correctly. The prefix operator that gets an error message. Okay, and let's push that. Okay, we should be able to see it. Percent of 32 should be a message. Yes. Cool. All right, and now operator. Well, this is close enough. Evaluates percent. So if you do 3% 4, 3 mod 4, we should get error expression of error messages dot percent not supported. And since we don't have it in our list, we don't expect it to work. Okay. This is dot percent, should be primitive functions dot convert to failure. Error messages dot percent. Good. Okay. Handle unsupported percent operator. And again, just to kind of keep the feel of what's going on in real life, but I'm not seeing anything here. I'm not seeing the other. So 20 mod 3 is an error. Okay. Cool. And float doesn't matter. Yeah. All right. Oh. That is an error. Okay. Handle types on operators. I'm wearing out on operators, I gotta say. What's the issue here? We we kind of do. I think we're doing what I expected there. I think we're done. Let's see. Let's look at our list. We only support arithmetic operators at this point, and plus, minus, times, up arrow for power, float or int divide, and percent for unsupported modulo. That should be the operators we expect to support. I guess I can add. I'll add for a later story. Support comparison operators, and another story is supporting, I don't know, function operators like this thing. And somewhere we have a list of all the operators. Yeah. Okay, so, and logical operators. So that's a functioning one. That's logical. And append. Okay. Well, logical. Or Boolean operators, I guess. Support. Boolean operators. Okay. We don't have the data types to do this one yet. We probably could do this one. I just haven't tried. These, we do have a bool type, and that's kind of related here. Although comparable probably includes string types or something like that. Maybe even appendable types. Okay. I'm gonna save that. I think we've done the types and the operators. Let's look at it. I might want to do some refactoring in there. Those names are still bugging me, but so convert to, and this thing is really, what's it doing? It's converting two functions. It's converting an int function and a double function to an expression. Well, let's call it something like that. Int function. How about convert? Convert function numeric types. And this one, convert to double, is convert function, let's just call it double. Because that suggests convert function int. Integer. And then the last one, convert to failure. That seems okay. Well, I think that's an improvement. Now the next thing, this curry, I almost want to pull the curry on the outside. Who references this? Interpreter. Well, okay. They want it curried. This one kind of does. Okay, I'll leave that. All right. I don't know how y'all are feeling, but I'm kind of tired of working with infix operators at this point. Let's just do something easy. Let's tackle this. The padding in the upper box. We did it at some point. I don't know what happened. We can close others. And this is our content view. So we have a vertical stack with all the lines and padding. And one way I can do this is like throw a giant number in there and see if it really looks funny. But maybe I'm not getting padded where I think I should get padded. Well, it's padding vertically fine. 3 plus 2. Okay, so 50 is too big. I thought it defaulted to 8, and that was fine. But I don't mind explicitly saying 8 if that helps. That's exactly kind of what I want to see. It looks... Yeah. Let's see if we specify it on the bottom box. Padding 40. Well, let's try it. And maybe we're adding, I don't know, we got 2 paddings there, one on the inner box, one on the outer box. It maybe that's going to be too much. Notice, I don't know if you can see this gray. There's a real light gray on the background that normally we show behind the text. Yeah, that's like way too much. Let's try 12. I'm just trying to get it to look similar to the bottom. I don't know that it has to be exact. I can live with that. Well, let's try 20. Yeah, I think that's pretty close. All right, let's go with that. We'll take an easy win. All right. Just padding in upper log box. Or maybe output. All right. And we can... Okay, so next time... Type must be constrained. Oh yeah, we didn't really do that one. How we handle function call is really a tricky thing. Let's pop in just the Elm language stuff. Syntax. All right, and we'll just kind of go down the list again and see where we are. I got comments, yes, we handle that. Literals, yes, but not characters or strings. Lists, we don't do. Conditionals, we do. This style, but not case statements. Records, we don't support. Functions, we do support. Anonymous functions, we support. We haven't checked for recursive functions and how we handle those. Let's do that. Applying, I think we do okay. We don't support appendables yet. Model, we haven't touched. Type annotations, we haven't touched. Type aliases, we haven't touched. Custom types, I don't know if we handle that. And JavaScript is not an issue for us. I don't know, we may fiddle with something and make a fake port. But so the real thing to me is I'd like to make sure recursive functions work, because that's kind of a thing. And then custom types would be nice. I think we support only, I don't think we support adding parameters to it. I think we just support bare names. But let's get that too. We don't have a Boolean hard-coded type. Well, I'm not sure how that's dealt with. We have something, but maybe it should be initialized a little better somewhere else, I think. All right, so our to-do, we're going to investigate recursive functions. I don't think we might handle it already. Investigate what we do for user-defined types. And how bool gets initialized. Okay, that'll keep us busy a little while tomorrow. So next time is tomorrow morning, Wednesday, 9 to 11:30 a.m. Eastern Daylight Time. Hope you can join me then or sometime in the future, and thanks for joining today. Bye-bye.